So as we're going through these equations, I'm noticing a pattern, and that is anytime that I'm dividing, I use the inverse operation of multiplication to undo that. So in this case, I've got x divided by 2. So I'm going to multiply the whole equation by the denominator 2 so I can get rid of that division, essentially getting rid of the fraction. So what happens? I have 2 over 1 times x over 2 equals 5 times 2 is 10. Got that? But 2 times x is 2x over 2 equals 10. So I've got 2x's divided by 2, which leaves me with 1x, really, because 2 divided by 2 is 1. So 1x equals 10, so x equals 10. And I take that, we've already worked that, we know that x equals 10, so I'm not even messing with checking it out. Let's try something a little bit more complex and say x minus 2 over 7 equals 2 and use the same theory. Sorry, my 7 was sloppy. So I want to take that denominator and I'm going to multiply the whole equation by the denominator of 7 to try to get rid of this fraction. So let's see here, 7 times x minus 2 divided by 7 equals 2 times 7. So what I get is 7 x minus 2, 7 times x minus 2 over 7 equals 14. And it's the same story again. 7 divided by 7 is 1. And I'm essentially, factoring that out. X, and that leaves me with x minus 2 over 1, which is x minus 2, equals 14. And I've seen this type of equation before, real easy to finish. I just do the inverse operation of subtract 2 from each side, and I have my answer. So I've got x minus 2 plus 2 equals 14 plus 2, which leaves me with x plus 0 equals 16, or x equals 16. Then I just take that, plug it back into the original equation to make sure it's correct. So my original equation would have been x minus 2 over 7, so I've got 16 minus 2 over 7 equals 2. 16 minus 2 is 14. Over 7 equals 2. 14 divided by 7 is 2. So 2 equals 2. Check. Now let's do this with something that's a tiny bit more complex. It's all right. We've worked this equation out before, so let's use this technique on an equation we've seen before. Negative 2/3 r plus 4 equals 6. And I just don't like the fractions, right? So if I just want to get rid of the fractions, I can eliminate them by multiplying the whole equation by the denominator. But to make it look a little better, I actually multiplied out negative 2/3 r. And what I get is negative 2r over 3 plus 4 equals 6. So I've got that denominator of 3. I'm going to multiply the whole equation by that denominator. This is where it gets a little tricky looking at it this way, because I have to use the distributive property on one side of the equation because there's multiple terms. So I do 3 times negative 2r over 3 and 3 times 4. So 3 times negative 2r over 3 is negative 6r. over 3 plus 3 times 4 is 12 equals 6 times 3 is 18. Now, I can see that 6 divided by 3 is 2, negative 2, r, which is what I originally had there. So you see my 3's kind of canceled each other out, and you might hear a teacher say that sometimes. Plus 12 equals 18. And now I've got a more normal looking equation without fractions that I know how to solve. Subtract 12 from each side to get rid of the plus 12, and I'm left with negative 2r equals 6. Negative 2 times r, so I'm going to use the inverse operation. And remember, I'm maintaining equality by doing the same thing on each side. Negative 2 divided by negative 2 is 1. R equals 6 divided by negative 2. It's negative 3. Take that, plug it back into the original equation, and check to see if it's correct. So I've got negative 2/3 times negative 3 plus 4 equals 6. So negative 2 times negative 3 gives me a positive 6 over 3 is what I'm going to get after I work this out. Plus 4 equals 6. 6 divided by 3 is 2. 2 plus 4 equals 6. 6 equals 6. Check. Thank you guys. I'm here all week. But seriously, watch this video again if you didn't really get it, or you can go back to doing it the other way if you get the other way a little bit better.